Hello everyone, welcome to Easy Explanation. So in this video I'll be covering the portion Hamming code, and in this Hamming code I'll be covering both error detection and error correction portion. So you can find this note under the course that is Computer Network and Security, and in this data link layer I have uploaded Hamming code, error detection and correction. So you can see the full note is here. So I'm going to explain how it works. So let's go to the whiteboard. So the topic is Hamming code. Okay, so in this Hamming code what we are going to do is we are going to check error detection. We are going to detect the error. For example, if you are going to send this data, okay, so whether there is error or not. For example, if there is error in this bit, for example this bit was originally 1, so we are going to detect this whether there is error or not, and also we are going to correct this particular error, that is we are going to correct this from 0 to 1. Okay, so the basic idea behind this Hamming code is parity bit. Okay, so I hope you know what is parity bit and how this parity bit is used in order to check the error. So in parity bit we have even parity or odd parity. Okay, so if we are going to consider 1, so the number of 1 in that particular data should be even if you are going to use the even parity. And if you are going to use odd parity, the number of 1 in that particular data should be odd. Okay, so that is the basic idea of parity bits, and this Hamming code, it was introduced by R.W. Hamming, and generally we use this Hamming code for 7-bit data. 7-bit Hamming you use. We can also use more than 7-bit, but generally we are going to learn for 7-bit, and this video also we are going to learn for 7-bit. So in this I'll be representing this data bit with D and parity bit with P. Okay, so let's move forward. Okay, so first of all let's see how to calculate the parity. So for example, if we have a 7-bit data to transfer 1 2 3 4 5 6 7. So in 7-bit, which all are the parity bit and which all are the data bit? So we are going to denote data by D and parity by P. So in order to calculate the parity bit is always calculated using the formula 2 to the power n, where n can be 0 to n. Okay, so in this let the position be 1 2 3 4 5 6 7. So now let's calculate the parity. Okay, so first of all the first case we will start from 0. So 2 to the power 0, it will be equal to 1. Hence, the first position is our first parity, that is P1. So let's name this as P1. Next is 1. Okay, from here. Consequently, we are going to take, so first n value is 0, now n value is 1. So 2 to the power 1, which is equal to 2. Hence, P2. It means that this second position, even P2 is our parity bit. So let's name this as P2. Now let's take 2. So 2 to the power 2, which is equals to 4. Hence P4, that is the fourth position, P4 is also our parity bit. Now if you see 2 to the power 3, you see that there is no 8th position because we are going to calculate this only for the 7-bit. Hence these 3 are the parity bit in our data set. It means that if this is our data set of 7-bit 1 2 3 4 5 6 and 7, from this first bit, second bit and fourth bit, sorry 1 2 3 4 5 6, so it becomes 8, so it became 8. So let me take the 7-bit 1 2 3 4 5 6 7. So if we take this 7-bit data set, so from here first bit, second bit and fourth bit are the parity bit, that is P1 P2 and P4, and remaining bits are the data bit. It means D3 D5 D6 and D7, these are the data bit. Okay, so we can say data bit they are 4 and parity bit they are 3. Okay, so this is the parity calculator, and also according to the Hamming, there is a formula that is P1 represents D3, D5 and D7. Using P2 we see D3, D6 and D7, and using P4 we see D5, D6 and D7. So this is a formula that you have to write, or you should know this formula. This is a formula that is generated by Hamming. Okay, and second thing is you have to decide whether you are working with even parity or odd parity. Okay, so in this whole video we will be considering that as even parity. In question, if they ask, they will be giving you either to use even parity or odd parity. Okay, so let's consider even parity and let's try to solve a question. So let's take an example. So this is a data bit. This is our data bit, which is 1011. So here we need to calculate this is a 7-bit. We are working for a 7-bit data set where data bit is this. Data bit is given, that is 1011. Here we need to calculate the parity P1, P2 and P4, complete the data set, and we need to send this data set. Okay, so while sending after sending we are going to detect the error, and also we are going to correct the error. So before detection and correction we need to send the complete data set, that is, this is the data bit portion only. We need to send the parity bits also. Okay, so this is the question where the data bit is 1011. So in this diagram, as I drew first, 1 2 3 4 5 6 7. If you see, this is our P1, this is our P2, this is our D3, this is our P4, this is our D5, this is our D6 and this is our D7. So from here 1011 we are going to put it like this, 101, and next data is this one. So now we need to calculate the parity. Okay, so how to calculate the parity? We know the formula. P1 is D3, D5 and D7, and in this question we are considering even parity. Okay, so what is D3? You can see it's 1. What is D5? You can see it is 1. What is D7? You can see it is 1. Okay, so 1 1 1, it is an odd number of 1. So in order to make it as even, we have to put the parity bit P1 as 1. Now you can see it has become even. If it was an odd parity, if we were using odd parity in question, the value of P1 would be 0. Okay, hence the value is 1 here. Now similarly, let's calculate for P2. So the formula for P2 is D3, D6 and D7. So what is the value of D3? 1. What is the value of D6? 0. What is the value of D7? 1. So you can see that the value of 1 is already even. Hence, we change this P2 to 0. Okay, I hope you are getting this. Hence, the value of P2 will be 0. Now, similarly, let's calculate for P4. So, we know the formula. P4 is D5, D6 and D7. So, D5 is 1, D6 is 0 and D7 is 1. Again, you can see the number of 1 is even. So, in order to make this all as even parity, we are going to change this value as, or we are going to put the value of P4 as 0 so that the number of 1 remains even. Hence, it is 0. Okay, so you can see what is the complete data set that we got. So the complete data set that we got is 1 0 1 0 1 0 and 1. 1 0 1 0 1 0 1. So this is the complete data set which contains data as well as parity, and we are going to send this. Okay, so why are we sending parity along with data? In order to detect the error if there is any. Okay, now this is the data set that we sent. Now me myself or we ourselves, let us alter one bit. Okay, so let us alter this d6 bit. Let us make this bit as 1 and send it, so that later we can check, we can detect and correct, we can detect that whether there is error or not, and if there is error, we should be able to correct this particular error only. So please remember, this is our original data set 1010101, and we are forcefully going to alter this bit as 1 and send this data, and let's see whether this Hamming code is able to detect and correct the error or not. Okay, I hope you got the point. So now let us suppose that the data set that is sent is 1110101. Okay, so you see what I have done, I have already altered this bit. Now we are going to detect the error. So this is the detection portion, very important. Okay, so now here we are going to just detect whether there is error or not. We are not going to see where the error is. Where the error is, that we are going to see in the correction portion. Okay, so in detection portion, the first step is, we know that P1 is D3, D5 and D7. Okay, so you know which all are the P1 and D1. So this is the P1, this is the P2, this is the D3, this is the P4, this is the D5, this is the D6 and this is the D7. Okay, so P1 is 1, and what are D3, D5, D6? Okay, so D3, D5, D6, they are 1, 1 and 1. So you can see the complete number of 1 is even. It means that there is no error in this set. Second case, P2, which is D3, D6 and D7. What is the value of P2? It is 0. What is the value of D3? It is 1. D6, it is 1, and D7, it is 1. So you can see here is an odd number of parity. Odd number, yeah? So there is an error because we have already considered even parity and we have set all the parity and sent. So it means that there is something altered here because we are getting odd number of 1. Let's check for P4. So it is D5, D6 and D7. So P4 is 0 and D5, D6, D7, again it is 1, 1, 1. So again you can see the number of 1 has come as odd, but we have considered even parity, hence there is error. It means that in these two set there is somewhere there is an error. Okay, so this is error detection. We have detected the error. Now let us go to the portion where we are going to correct the error. Okay, so now let me make a question, same question. So I'll be sending the same data. So the question is if the 7-bit Hamming code word received is 1110101, assuming the even parity state, okay, whether the received code word is correct or not. If wrong, locate the bit having error. Okay, so if you don't understand this question, please go and see our website. There I have uploaded the question. The same question is there. I am solving the same portion of the note that I have uploaded. Okay, so the question it's saying is that this is the Hamming code that has been received. Okay, and also we are going to assume the even parity. So first of all, you see whether there is error or not, and if there is error, also correct the error. Okay, so again the previous portion we are going to repeat because we are going to detect the error. So again the steps are for detecting the error. Okay, so this is our data set 1110101. So for detecting the error, we have the formula P1 is D3, D5, D7. P1 is 1, D3, D5, D7 are 1. So you can see that the number of 1 are even. So we have used even parity, hence there is no error in this. Step 2, P2, consider D3, D6, D7. You can see the value of P2 is 0. And okay, so one thing I missed. So while correcting the error, if you see that there is no error, if there is no error, we just make the parity as 0. We are not changing this parity, okay? We are just setting the, so there is two cases. If there is no error, set the parity as 0. If there is error, set the parity as 1. This is just a rule, okay? We are not changing this from 1 to 0, but we are going to set the parity bit as 0. If there is no error, the parity bit as 1 if there is error. Okay, so in second case, we have D3, D5, D7. So we can see it is 1, 1 and 1. So you can see the number of 1 is odd and we have used even parity. Hence, there is an error. So we are going to set the P2 value as 1. Okay, next case is P4, which is D5, D6 and D7. So P4 is 0, yeah, and D5, D6, D7 is 1, 1, 1. Again, there is number of 1 is odd, but we have used even parity, hence there is an error. And if there is an error, we are going to set the P4 value as 1. Okay, so these are the three values that gone. We got the P4 value as 1, P2 as 1 and P1 as 0. Fine, so the P4 value is 1, the P2 value is 1 and the P1 value is 0. Okay, so let's put the P4, P2 and P1 in 1 plus, that is P4 is 1, P2 is 1 and P1 is 0. Now this is a binary form. Please change this to the decimal form. So if we change this to decimal form, we are going to get the answer as 6. Hence, the data value or the data bit having 6, that is D6 value, there is an error. So the 6 represents the number, that is, so what was our code word that we sent? 1, 1, 1, 0, 1, 0, 1. So first we detected the error and now using converting this to decimal number, we have got that the D6 value, the place where the 6th value or the 6th value having the data is having an error. So you can see the bit is 1 here. So in order to correct the error, we are going to change this 1 value to 0. Hence we got the answer as 1010101. So if you have watched my video, this is the original data set that we sent. Okay, so hence using the Hamming code we have corrected the error. So that's all for the video. I hope you got, and please for note portion, please go through this note because the same question I have solved. Okay, so I'll be providing the link of this course or this explanation in my video. Please, if you need me to solve any other question, please comment below. Thank you and best wishes for your exam.